A reinforcement plate has the shape of a triangle ABC with altitude AD is equal to 5.7 centimeters, DC equals to 7.6 centimeters, and angle B is 42 degrees as shown. So here we have the diagram, and they want us to calculate the length of the edge AC. And so let's focus on this particular right angle triangle, and they want us to figure out the length of the edge AC. So they want us to figure out what is this side. Now, we're gonna call this side, C, right? That's the hypotenuse. All right, so we're gonna call this C. The hypotenuse is the longest side. It's also the side that's opposite the right angle. We're gonna call this side A. So A is gonna be equal to 5.7. We're gonna call this side B because so we have A, B, C, and so we label them as such so that we can use the Pythagoras theorem to figure out what is the length of side C, or how they label it, the length of AC. And so the Pythagoras theorem states that C squared is equal to A squared plus B squared, where C is the hypotenuse. All right, that's the longest side right now. Now, we don't know what C is, but we do know what A is. A is 5.7, and we know that B is 7.6. And so we substitute them in. We have 5.7 squared, and that gives us 32.49, and we have 7.6 squared, which gives us 57.76. Next, we add these two together, and we get that C squared is equal to 90.25. Next, we take the square root of both sides. And when we do that, we can cancel this with that, leaving us with C is equal to, leaving us with C is equal to the square root of 90.25. Now, what is the square root of 90.25? Well, that's going to be 9.5. And so C is equal to 9.5. But C is the length AC. And so that means that AC is going to be equal to 9.5. And that's the answer to this question. Next, they want us to calculate the length of edge AB. Now, when we say AB, we're talking about this particular side. And so what we have to do is we are zeroing in on this particular right angle triangle. Let's label the triangle that we have. So this right here is theta, that's the given angle. The side that is opposite the given angle is called the opposite side. And we also have the side that's opposite the right angle, we call that the hypotenuse, and the side that's left is the adjacent. Our goal is to determine what is AB, what is the length AB, or what is the length of the hypotenuse. So we need to figure out what is the hypotenuse, all right? And we have the opposite side. So those are the two sides that we're concerning ourselves with. The hypotenuse, because that's the side that we want to find, and the opposite, because that's the side that we actually have. And so we're going to use a trig ratio that uses the opposite and the hypotenuse. Opposite and hypotenuse, that's going to be sine of theta. And so we have sine of theta is equal to the opposite over the hypotenuse, where the opposite is 5.7. The hypotenuse is unknown, so we call that x. And theta is 42 degrees, just like how it is here, right? And so we're going to put sine of 42, we're going to put that over 1. And this is going to be equal to 5.7 over x. And we do that so that we can cross multiply. And so we have x multiplied by sine of 42. So x times sine of 42, and 1 times 5.7, which is 5.7. Next, we are going to divide both sides by sine of 42. And so this is going to cancel with this. And so we have that x is equal to 5.7 divided by sine of 42. Again, x is equal to 5.7 divided by sine of 42. And so when we divide that, we get x is equal to 8.51851633.4. Now we're going to round. We're going to round correct to 2 decimal places. Notice that this right here is 8. And so since this is 8, once it's 5 or above, we could round up. So we add 1 to 1, and 1 plus 1 is 2. So we have 8.52 centimeters. And that's how we got AB. AB correct to 2 decimal places. That's our answer here. Next, what we have is we have to calculate the angle AC. ACD, the angle ACD. So this is A, C, and D. But we're trying to figure out what is this angle, right? I'm sorry, we're trying to figure out what is this angle because that's the one in the middle. So angle ACE. So we're trying to figure out what is this missing angle. And so what we're gonna do is we're gonna zero in on this particular right angle triangle where we're gonna call this theta. And so theta is the missing angle. That's what we're trying to find. Let's label this triangle. The side that is opposite theta or the side that's opposite the missing angle is what we call the opposite side. The side that's opposite the right angle is called the hypotenuse, and that's 9.5. And we figured that was 9.5 from part A of this video. Also, we have this is the hypotenuse, and then we have the adjacent, which is the adjacent is the side that's left. So the side that's opposite the angle is the opposite side. The side that's opposite the right angle is 9.5, and the side that's left is the adjacent. Now we have to determine, again, remember our goal. Our goal is to determine what is this angle, right? What is the measurement or the size of this angle, theta? We have what is the opposite, that's 5.7. We have the hypotenuse, that's 9.5, and we have the adjacent, that's 7.6. So we can use any of the three. We can use any of the three trig ratios because we have all three of the sides. But I'm going to use the sides, the adjacent and the opposite. Now, why am I using these sides, the adjacent and opposite? Is because I want to use the sides that were given. So not the side that we had defined. So we had to find out what is 9.5. I'm using the sides that were given to us. And so it's just a safer route in general. And so that means that we're going to be using the opposite and the adjacent. Which trig ratio deals with opposite and adjacent? Yes, you're right. That is tangent, right? So tan consists of opposite and adjacent. And so we're going to use tangent. Tan of theta is equal to opposite over adjacent, where the opposite is 5.7. The adjacent is 7.6, as you can see on the diagram. And next, what we're going to do is we're going to take the tan inverse of both sides. And when we do that, we can cancel out this tan inverse along with this tan, and we are left with theta is equal to tan inverse of 5.7 all over 7.6. And so that means that we have to take tan inverse of this particular division. And when we do that, we get theta is equal to 36.86989765. And so what we're going to do is we're going to round this correct to 2 decimal places. Notice here that 9 is greater than 5, so that means that 6 is going to be 7. And so we have that theta is equal to 36.87 degrees. And so that means that the angle ACD is equal to 36.87 degrees. And that's the answer to this question.